Major support has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Panama Buena Vista Union School District, and the Kern High School District. With additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Today we are at Kern Regional Crime Laboratory and I'm with Kelly Woolard. How are you doing today?
Good, thank you.
And can you kind of tell us where we're at?
Right now we are in the Firearms and Toolmark Unit Laboratory.
And can you kind of give us a little background about yourself?
Yes, well I have a science degree and that's how I was able to be hired as a criminalist at the laboratory. When I was transferred into the Firearms and Toolmarks Unit, I had specialized training that was specific for a firearms examiner. We had to learn about ammunition components that have been fired through a firearm, bullets and cartridge cases on a comparison scope. Our training is an ongoing process, so we are continuously training and going to classes, seminars.
So when you receive evidence here into the laboratory, can you walk us through the process?
Yes, so that all evidence comes through our evidence control unit, and that gets logged into the laboratory. It's given a specific laboratory case number, and then we pick those items up that need to be examined in the firearms unit, and we bring those back here into the laboratory where we conduct our examinations and comparisons.
And so you kind of conduct those in a room over here, right?
Yes.
Okay, can you kind of walk us over there? I know that you have some things up on the computer that you're going to show us.
Yeah, so once I've already gone through the process of looking at the evidence items that have been received at my workstation with the lower power microscope, I then come here to run some samples through our database to conduct a search.
So you've taken, obviously, photographs of the evidence?
Yes, yes.
Okay, so kind of walk us through what you have here on the screen.
So this is our database station workstation. It's called Evo Finder. At this station, we take cartridge cases or bullets that have been fired from a firearm, whether it's the evidence at the scene that was collected at a crime scene or from test fires that we've generated from a firearm that law enforcement has submitted to us. We place the ammunition here, we place it inside, and this will scan the evidence item and it'll generate an image, and we will look for possible links or matches that we then can give to our agencies. We generate a report, a possible investigative lead.
So these are two different pictures?
These are two different, yes, and I can show you a little bit so I can move these around.
How do you know that they line up? What specific traits are there that tells you that these are the similar?
Well, that's a really good question. So I'm going to move these apart because it really looked like one cartridge case. So these are actually two individual evidence items. And what I was lining up here, these are called the aperture shear. And the aperture inside of a firearm is actually where a cartridge case will sit against. It's the opening that the firing pin travels through to strike the primer. Inside the primer, there's material that provides the initial spark, and that is the gunpowder or the propellant, and then that is what expels the bullet through the barrel and out of the firearm. This is the firing pin impression. So both of these firing pin impressions are the same. Not all firearms have the same shape firing pin impression. This shape of this aperture shear or the opening has imparted a mark onto the cartridge case, and that's what happens because of the high pressures inside of the firearm and the movement of the cartridge case. So these can be very unique marks. So there's also marks here. You can look on here. That is from the breech bolt where the cartridge case was sitting against and made contact with. And so we can see, I can see those marks here and I can see those marks here. And you can see that those line up as well. So there's a lot of areas that are lining up. These are called striations or marks or impressions with the firing pin that are all very similar between these two different pieces of two different evidence items from two different cases. And I'll show you again the aperture shear marks right here, this area here, though there's a lot of areas that are lining up and that are very similar.
So each kind of firearm has a different signature like inside of it.
Yes, it can, but not all firearms are going to impart markings. Not all firearms impart really good markings. Some are better than others. And sometimes it might have to do with what the metal composition of the cartridge case is. It just depends of a firearm.
We're going to kind of look closer at this underneath the microscope in a second.
Yes.
Because that's the next process, correct? Once
Yes.
you've done this and you were working over there. Okay, so when we come back, we're going to be looking a little bit closer underneath the microscope at the casings. We are back at the Kern Regional Crime Laboratory, and I'm with Kelly Woolard. And Kelly, we had just talked about when you gather the evidence, you actually physically look at it, and then we took it over to the computer where you scanned it and tried to find matches. Now we're again physically looking closer at the evidence.
Yes, so if you see here, I have, this is a high power comparison microscope. I have the actual cartridge cases mounted one on each side, and these are joined by an optical bridge up here, and when I look through here, it looks as though those two are side by side. So I look through here and I can adjust the magnification here if I need to. I can adjust so things look clear to me. And then I have over here on the screen, the computer screen, I can see the images as well. And so this is what it looks like when I'm looking at this under the microscope, as though they're side by side. So I can maneuver these around. So we can see here that these two are, and I can adjust the lighting if I need to. This is a little bit bright on that side.
So my wonder, Kelly, is that has one been fired and one has not?
No, these have both been fired. These are both fired pieces of evidence. And so we talked a little bit earlier about sometimes things mark better when they've been fired. That's a really good example here. On the right side, this one has a lot more markings from the firearm. This one only has a few as far as right here on the breech. But there are lots of areas that the firearm can mark a cartridge case. So this is just the head of the cartridge case. I can actually look on the side of the cartridge cases for chamber marks that may have been imparted from being inside of the chamber. So right now we're just looking at the firing pin impressions and these markings here from the aperture and the breech. But even though on the left side there's not a whole lot of markings, you can see that if I move these together, what is there is actually still lines up. Even though it's not a whole lot for the left side.
Now, were both of these cartridge cases evidence at the scene?
Actually, these are different. So these are test fires from a firearm that was received at the laboratory. We also compare the test fires to each other prior to comparing to the evidence items because we want to see if the firearm reproduces marks, what types of marks they're reproducing. If we can't identify those to each other, then we cannot make an ID to an evidence item.
So you've also received the firearm in addition to this evidence as well?
Yes, this one had a firearm that came into the laboratory.
Okay.
So these are called individual marks. These are like the unique microscopic marks that can be imparted to a cartridge case from firing. But a lot of times we could rule things out based on the class characteristics. And the shape of the firing pin here, you can see it's kind of like a little half circle. We call that hemispherical. That is a class characteristic of the firearm, and that was determined by the manufacturer prior to manufacturing the firearm. So everything that was manufactured to those specifications would have the same shape firing pin impression. So if there was a firing pin that was a different, let's say it was rectangular shaped, that is something that I could easily rule out before we wouldn't even come to a microscopic comparison because those would be different class characteristics. Or for instance, if they were not the same caliber of firearm, then those are automatically ruled out. So we wouldn't even be here at this part because those class characteristics would have been an elimination.
Can you give us an example of what that would look like?
Yes. So this one here, this is an example of, well, first of all, these are two different calibers. The one on the left is a 9mm, the one on the right is a .380 auto. There are instances where sometimes people do shoot the wrong ammunition in a firearm. These are two examples of something that could have happened, even though you're not supposed to. But we can see here that even though, so their firing pins both have a similar shape, they're both the hemispherical. There's a lot of differences on this breech area and with the aperture shear here too. This almost looks like we've got some curvature to the marks here, some kind of circular. So these are very different in appearance. You don't have the striated marks, the linear marks that you have on the right side. I'm going to kind of turn this around here, flip it around. Looks like a little bit, you see a little bit of the aperture there. It's not a whole lot, but again, kind of have these circular marks a little bit going on here that are very different than the linear marks.
So there is just so much more involved here. When we come back, we have so much more to look at. And we are back at Kern Regional Crime Laboratory. Now, we were kind of looking at the evidence when you retrieve it in, correct? A little bit deeper look. Can you kind of tell us where we're at right now?
Yes, we actually have a firing range at the laboratory. So this is a one-lane indoor firing range. And down this range, we can shoot high-powered rifles or shotguns. We don't collect the bullets when we fire down here, but we do collect the cartridge cases or the shot shells. So we will fire down the range here. We then will collect the shot shell or the cartridge case from the firearm, and this is what we can use to either put into our database or to compare on the comparison scope.
So what else, besides here, where else do you use in this area to help you with the evidence?
Well, when we need to collect a bullet, we actually have a water tank that we can test fire handguns, mostly handguns, into the water tank, and that will actually we can collect a bullet in pristine condition.
Why water?
Well, what we do is we actually turn on the jets, and that decreases the water tension. It breaks up the water tension so it doesn't damage the bullet.
Okay, can you show us the water tank?
Yes.
And we are here also with Allison Kennedy.
Yes.
Hello. Walk us through how you use this.
So here I have turned on the jets and a light inside of the tank. You can hear the water. It sounds like a spa. And so this is the opening that we test fire into with the firearms. The cartridge cases usually will be kicked out from a semi-auto.
So how do you collect the bullet out of here?
Okay, well first we turn off the jets, and we come over here, and Allison will help to secure the lid. It's very heavy. Okay, so as you can see here, we then have to look for the bullets. Sometimes it's a little easier, sometimes they hide behind this mat, but we have one right there. We can see the bullet. It's actually a very large bullet. So we have some putty on the end of this, plumber's putty that we use on the end of this rod, and we can retrieve the bullet. It's kind of a two-man operation here, two-person operation. And then you can see that this bullet is not damaged. Like oftentimes we get bullets from crime scenes that are damaged because they've hit an item or gone through an item. And so these, we can see some lands and grooves that have been imparted from the firearm, from the barrel, inside the barrel. So this is good for analysis and comparison.
Very interesting. And Allison, can you kind of tell us what your position is here at the lab?
I am a supervising criminalist here, and I help manage the firearms and tool marks unit as well as the crime scene response team.
So if somebody was interested in becoming an analysis, what process would they need to do?
Well, the very minimum to become an examiner or analyst here at the laboratory is to have your Bachelor of Science degree in science, whether that's chemistry, biology, or some other related science.
And then Kelly talked about, again, that 2-year process, correct? Is there another process to go through, some more training besides that?
Once an individual's hired, there's a training process depending on what unit they're assigned to, and for the firearms unit, it can be 2 to 3 years. Other units in the laboratory, some are shorter, some are longer. The best examiners here at the laboratory are very much like Kelly, very detail-oriented, very good at recording observations, and obviously have a keen sense for science and math.
So really focusing on those science classes.
Yes.
Well, ladies, again, thank you so much for letting us come to the lab. And again, just a little appreciation. We always love coming here and visiting. And thank you again so much for walking us through all the evidence and everything here. Thank you again. And that's it from the Kern Regional Crime Laboratory.